Hello. Today we're going to look at states of matter that are commonly found in a chemical reaction. So we're going to try to identify states of matter in chemical reactions. There are really four states of matter that are common in chemical reactions in high school chemistry. And the first is one that's familiar to you. Most students have no trouble identifying a solid. In a chemical reaction, solids can appear in the form of an ash, or a powder, or crystals. Most metals on the periodic table, except for mercury, are going to be in the solid form, so any metal that you're going to have. But the state of matter that's usually new to students for a solid is the concept of a precipitate. Precipitation. Oh no, we're not talking about rain, snow, sleet, or hail. When we talk about precipitate in chemistry, precipitate is a solid that forms in a chemical reaction between two solutions. And what happens is what's similar to this very first picture. You've got what looks like nothing, it's a solution, and what looks like nothing, but really in these solutions, there's things that are dissolved, and when you mix them together, it becomes cloudy. That cloudy is what we refer to as precipitate. Now, because it's in water, it's hard to identify as a solid, but if you dump that into a filter and let it dry, you would end up with something that would form a powder or a crystal. The picture on the right gives a much better example or visible sample where you can identify it as a solid, but precipitates commonly look much more like what you're going to identify here versus the obvious one that you might see on the right. Precipitates and solids are very common in a chemical reaction. The second state of matter that you run into in a chemical reaction is what we refer to as a liquid. Oh, and this one is deceiving. Be very, 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 very cautious with a liquid, because in order to form a liquid, it needs to melt. In this level of chemistry, we spend a lot of time with ionic compounds that are known for their very high melting points. So if we look at NaCl, NaCl has a melting point of 801 degrees Celsius, or 1474 degrees Fahrenheit. Your house could burn down, and the table salt in your house would probably still be a solid. So the reality of using liquids in this level of chemistry is very unlikely. In fact, there's one liquid that we deal with frequently in this level of chemistry, and that liquid is going to be water. Students are very quick to pull out the liquid label when we're talking about chemical reactions, but unless you're putting it on water, it is very unlikely that the substance you're dealing with is actually in a liquid form. The third state of matter that we deal with in chemistry is something students identify pretty easily in a chemical reaction. It is a gas. In a gas, it will be seen as steam or smoke or bubbles or fizzing. And if I showed you a chemical reaction right now, most of you would be able to readily identify the gases that actually formed. The fourth state of matter that we deal with is a new state of matter, and that's aqueous. Aqueous is abbreviated as an AQ. And yes, sometimes students mistake that as a G, but that is going to be a lowercase q, and make sure we're writing it as a Q and not a G. Aqueous means dissolved in water, and this is going to be the most common form that you're going to see in ionic compounds, because ionic compounds don't melt. Well, they do, we just not in average temperatures. So what happens when we put it in water, we know table salt dissolves. And that forms a specific state of matter where we can use ionic compounds in chemical reactions. So aqueous is going to be very, very common when we talk about chemical reactions. Keywords to look for, well, if it's dissolved in water, we commonly refer to it as a solution. and we'll use the word dissolved. So where do those chemical reactions come up? Well, when you see a chemical reaction, you frequently see symbols alongside of it to tell me what state of matter it is. So this potassium sulfate is AQ, which means it's dissolved in water. This barium chloride is also going to be AQ, which is dissolved in water. And potassium chloride that's produced is also going to be dissolved in water. The remaining product, this barium sulfate product, is going to be S, which means it's a solid, and this would actually be what we refer to as a precipitate, but we will get into that a little bit more later on in the term. So aqueous is going to be a very common state of matter that you're going to run into in a chemical reaction. The other way that you will see chemical reactions is in word equations, where you are supposed to identify what states of matter there are. So this tells me that it is aluminum sulfate solution. So when I write this out, I not only need to write the formula for aluminum sulfate, which is an ionic compound. Aluminum is going to have a 3+ charge, and sulfate is going to be SO4, the 2- charge. So this would be written as Al2. The SO4 goes in parentheses, and there's going to be a 3 on the outside. But because this is a solution, the state of matter for this would be AQ. And so I would write into it, next to it, a small lowercase a and a q to tell what state of matter that is. That means that it's dissolved. And of course is my plus sign. This is calcium hydroxide, another ionic compound. Calcium is Ca. Calcium is going to be a 2+. Oh, be careful with hydroxide. That's a common error. It is a polyatomic made up of oxygen and hydrogen that has just a 1- charge. So calcium's 2 goes to hydroxide, and since it is a polyatomic, polyatomics always go in parentheses when we write a subscript. This tells me that this is also a solution. That means that this is going to be dissolved. And it is going to produce, that becomes my arrow. And it is going to form a precipitate. Well, if we go back up, precipitate is going to be the solid that forms in a chemical reaction, much like taking this solution and this solution to form this little wispy white stuff. It's a precipitate. So when I see precipitate, precipitate is going to be a solid of aluminum hydroxide. So still ionic. Aluminum still has its 3+ charge. Now it is paired with the hydroxide, which is still a -1. So hydroxide still goes in parentheses, but this time it gets a 3 from aluminum. Now when this is a precipitate, it's going to get a symbol of an S as a little subscript. And as a plus sign, it's going to form a solid, so another precipitate. And this is going to be calcium. And it's going to be sulfate. Since calcium is a 2 and sulfate is a 2, those charges are going to simplify out, and I don't write them. And I'm going to complete this equation by putting an S. Yes, both of these equations would need to be balanced, and to balance these equations, I would need to put a 2 in front of here. That gives me 2 aluminum on both sides. I have 3 sulfate, so I would have to put a 3 in front of here. That gives me 3 sulfate, but it also gives me 3 calcium, so I'm going to put a 3 in front of my calcium. And I have 6 hydroxides and 6 hydroxides, and it's a balanced equation. So, common states of matter in chemical reactions. Aqueous. You run into aqueous frequently. Solid. Liquid, water only, and gas.